We're going to work through our exam review. So we'll just start with number 1 and work our way all the way to the end. So we're going to solve each equation here by factoring. Now when solving by factoring, these are quadratic equations. Each one of them, they have a squared term. And so when we solve by factoring, we want to get all the terms on one side and set it equal to 0. So we're going to subtract 3x from both sides. When we subtract 3x, we're going to go ahead and put this in descending order. So we put the x squared, then the x term, then our constant, and that's equal to 0. And now we think through factoring. And we know we need an x here and an x here to get the x squared. There's a negative here, so we need a plus and a minus because a negative, positive times a negative gives me negative. And then we can think through the factors of 28 to help us get this negative 3 in the middle. So it looks like we're going to have positive 4 and negative 7. You can check the inner 4x and negative 7x, and they do add up to equal to negative 3x. And now that we have it factored, remember all we have to do now is we have two things that multiply together equal 0, so x equals negative 4 or x equals 7. Moving on to the next one, very similar. We're going to add 14p to both sides. And again, when we write this, we're going to put it in descending order, so we put the p squared plus 14p plus 48 is equal to 0. We want to factor, so to get a p squared, we need p at the beginning of both factors. To get a positive 48, it's either going to be two positives or two negatives to get a positive. Well, we look here and realize we've got to have two positives. And then 48, you can think of the factors. You don't have to write them out, but you're looking for two factors that in this case will add up to equal 14, and that's 6 and 8. So what makes this factor 0? Well, p be negative 6, so negative 6, or what makes this factor 0? Negative 8. Moving on to number 3, we could subtract r squared to this side, but I usually like to have my quadratic term positive, so we'll go ahead and subtract 16r from both sides. And we'll add 64 to both sides, so we can set it equal to 0. And we get r squared minus 16r plus 64. Sorry, the 64 is written weird. It just was running out of room. And that's equal to 0. And now we go to factor again. We need an r and an r. And I'm not going to write down all the factors of 64 this time. 1 and 64, 2 and 32, 4 and 16, and then 8 and 8. We have a positive, so we need the same sign here and here. And in this case, we look here, we need two negatives. And it looks like it's going to be 8 and 8. And so r either equals 8 from this one or 8 from this one, but we don't need to write it twice. It's the same answer, so r is equal to 8. So that's solving by factoring. Moving to the next group is solve by taking square roots. So these are still quadratic equations. It's just that we're going to use a different method. We can solve by taking square roots when there's a squared term, there's no linear term, so there's no term with just an x in it, and there's a constant or constants. And so what we want to do here, we want to get the constant on one side. So we're going to subtract 9 from both sides. And then we want the squared term on the other side, so we have 100x squared equals 36. We want to solve for x squared, so we'll go ahead and divide both sides by 100. Which gives us x squared equals 36 100ths. We can factor here, or we could take the square root. Either way is fine. Reduce here, or take the square root. So actually we'll rewrite this 36 over 100. Let's go ahead and take the square root of both sides. We take the square root of both sides, we make sure we put plus or minus, and we get x equals the square root of 36. 6, the square root of 100 is 10, and that reduces a bit more to plus or minus 3/5. So I do want your answer in reduced form, and don't forget the plus or minus. Moving to this next one, once again, it's got a quadratic term, and then it has some constant terms. We want to get the constants on one side. So we'll go ahead and subtract 4 from both sides. I don't know why I keep having trouble with these 4s and it looking like 9s. But we have 5m squared equals negative 86. Divide both sides by 5 to get the quadratic part by itself. And we get m squared equals negative 86 over 5. We want to solve for m, so we'll take the square root of both sides. Make sure we put plus or minus. And we have m equals plus or minus. Now we have the square root of a fraction, so we have a couple things we want to work with here. We have a negative under a square root, so that means we are going to have an I as part of our answer. So we're going to bring out the negative. It's really bringing out a square root of negative 1, and we write I. And then we're going to think of this as the square root of 86 over the square root of 5. And we're not supposed to leave a radical in the denominator, so we'll multiply both the top and bottom, which we'll see a little bit later, simplifying radicals on this review. Multiply top and bottom by the square root of 5, and we get our answer for m. So we can put plus or minus. Oftentimes we put the I afterwards, so we'll do this. This is square root of 430. 86 times 5 is 430 over root 5 times root 5 is just 5, and we have an I. So there's our answer for that one. And coming to number 6, again, it's similar. Add 6 to both sides. So we have the quadratic term on the left side, constant term on the right side. We have 540 here. We'll go ahead and divide both sides by 6. We get x squared. 540 divided by 6 is 90. We have x squared equals 90, so we'll take the square root of both sides. We put plus or minus. Oops. Do this in red. So take the square root of both sides. On the left we have x. On the right we have plus or minus the square root of 90. Well, 90 we can factor down. You might be able to just do this in your head, but this is 2 times 3 squared times 5. And we can take the square root of this 3 squared, which is 3. And we get 3 plus or minus 3, and then 2 times 5 is 10, root 10. All right, so that's solving by taking square roots. Now we're going to solve by completing the square. We actually don't have the more difficult ones on here where we have a coefficient out here. So these are pretty straightforward. First thing we want to do is get the constant to the right side. So we'll subtract 72 from both sides. And we get n squared minus 2n equals negative 74. Notice I left a little gap here because what we're going to do now is complete the square. We take half of negative 2. We don't use the n. We take half of negative 2, which is negative 1. And we square and add it to both sides. So over here I put it in this form, but then over on the right side I'll go ahead and think negative 1 squared is 1. So I'll add 1 over here. We do that because now this left side factors. We don't always show the work, but this factors to n minus 1 squared. This number and this number we have here equals negative 74 plus 1 is negative 73. Now we're kind of like to the problems we just did solving square roots. We need to get rid of this squared. Sorry, solving by taking square roots. Put plus or minus. On the left we just have n minus 1. On the right we have plus or minus. This was a negative under here, so we're going to have an I. So we'll write root 73i. And then all we have to do is add 1 to both sides. Oftentimes we put the rational term first, so we're going to put n equals 1 plus or minus root 73i. Jumping right into number 8, we want the variables on one side, the constants on the other, so we'll add 6 to both sides. We have x squared minus 14x, we'll leave a gap, equals 15. We take half of this negative 14, which is negative 7, and square it. So that's negative 7 squared, which is 49. So we added 49 to the left. We need to add 49 to the right. We have x minus 7 squared. So if we took this x squared minus 14x plus 49 and factored, it factors to this. The easy way to do it is it's this x and then this minus 47. If we had a positive, we would put plus there. Over here, this adds up to equal 64, which turns out kind of handy because we're going to take the square root of both sides. And on the left, we have x minus 7 because the square root cancels with the squared. On the right, we have plus or minus, and the square root of 64 is 8. So to finish this off, we want to add 7 to both sides. But since the square root of 64 simplified to just 8, we can go ahead and think of this as two things. We got 7 plus or minus 8. And so we think through this, x equals 7 plus 8 is 15, and 7 minus 8 is negative 1. So our answers, we have two answers for this one, it's 15 and negative 1. All right, the last one, last from this group. Now we're going to solve each by using the quadratic formula. So let's put the quadratic formula over there. The variable, whatever we're dealing with, so really the proper way to write it, if we have an equation in the form ax squared plus bx plus c equals 0, the variable x, or over here we'll use m, is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Know that formula. So now notice we want to use this formula, but we have to have our equation in this form. So it's kind of like up with 1 through 3, we wanted a 0 on the one side, so that's what we're going to do here. So when solving with the quadratic formula, you want to have 0 on one side. So in this case, we're going to add 4m. Make sure you put it in descending order. So we have 3m squared, then plus the 4m, then minus 119 equals 0. It has to be squared to the first and then no variable at all. So now we can think through, well, a is equal to 3. It's right there with our m squared. B is equal to 4, and c is equal to negative 119. And now we plug these in here for a, b, and c. We don't put the letter m at all in this. We just plug in 3, 4, and negative 119. So m equals, so instead of putting x equals, we're putting m equals negative b, so negative 4, plus or minus the square root of b squared, so 4 squared, minus 4 times a times c, all over 2 times a. And so we get m equals -4 plus or minus the square root of 16. So we square this first. And now we have 4 times 3 times -19. Let's put a parenthesis so it's a little more obvious. And so we have 12 times -119. So we have our negative sign, and then we multiply 12 times -119, and we get -1,428. But now we want to combine these. Actually, let's put over 6. So we have m equals -4 plus or minus the square root, and this is 1444, 1,444, because 16 minus a negative is positive, over 6. And the square root of 1,444 is, so the first thing you want to do is check with your calculator to see if it's a perfect square. And in this case, it is. It's 38. And now we actually have two things here. We're going to do -4 plus 38. So -4 plus 38 is 34 over 6. Or we can do -4 minus 38, which is -42 over 6. And simplifying this, simplify by 2. This is 34 over 6, so that reduces to 17 over 3. And this one equals -7. So our answers are 17 thirds and -7. So set it equal to 0, find out a, b, and c, plug them in, and then simplify. Next one, we'll want to add 9 to both sides, because when using the quadratic formula, you want 0 on one side, so we have 8x squared plus 9 equals 0. So we only have 2 terms here, so we have to be careful. A, it goes with the squared, so a is 8. B is what goes with the x term. Well, there is no x term, so b is 0, and c is the constant. And so we're going to plug that right into our quadratic formula. So we have x equals -0, which is just 0, plus or minus b squared, so 0 squared, minus 4 times a, which is 8, times c, which is 9, all over 2 times a. So x equals -0, which is 0, so plus or minus square root 0 squared, which is 0, minus 4 times 8 times 9 is 288, so -288, all over 16. Now we want to simplify -288. So what I would do actually is I would think, well, I know 288 is 144 times 2. Also, I want to mention this is a -288, so we're going to make it positive, but we have to put an I out here. And the reason I'm using 144 is because 144 is a perfect square. So what's the square root of 144? Well, that's 12, so we have plus or minus 12. Still got a root 2 here, root 2i over 16. And now we can reduce things that are not within the square root. So 4 goes into this 3 times. So we have plus or minus 3 root 2i, and 4 goes into 16 4 times. So maybe I should have just done this. 4 goes into this 3 times, 4 goes into this 4 times, and then we have our answer.